Welcome to Math 043, Slopes and Rate of Change. Slope is a number which describes the steepness of a line. A line with a positive slope rises as it moves from left to right. The purple line is a positive sloping line. Its rightmost arrow is pointing up. A slope A line with a negative slope falls as it moves from left to right. So the green line, the rightmost arrow, is pointing down. Therefore, it has a negative slope. There are several ways you can calculate the slope. Most commonly, if you have a ordered pair, you will take y2 minus y1 divided by x2 minus x1. Slope is also defined to be rise over run, or delta y over delta x, which means the change in y over the change in x. We have some special cases. A horizontal line has a slope of 0, which is in the last lesson why I said hoi. Horizontal line has a slope of 0, and the equation of the line is y equals. A vertical line has an undefined slope, and the equation of a vertical line is x equals. In the next set of examples, we are going to find this slope from a graph. So we're going to count the vertical change divided by the horizontal change. So we can start at either point. I'm going to start here. I'm going to count 1, 2, 3, 4, 5, 6, 7. So that is a rise of 7 and a run of 1, 2, 3. So we would describe the slope as a positive 7/3. Doesn't matter from which point you count from. If I started at the top, I would go down 1, 2, 3, 4, 5, 6, 7. And then I would go over 1, 2, 3. So the slope would be negative 7 over negative 3, which simplifies into 7/3. Example 2, I go up 1 and over 1, 2, 3. But that 3 is to the left, which should make sense because the line is sloping downward. I could also start at the other point. I would go down 1 and then over 1, 2, 3. I still have a slope of negative 1/3. For example 3, I can pick any 2 points on the line. And there is no vertical change. I don't go up any. So I'd have 0 over 3, 0 over any number. And anytime you have 0 in the numerator, 0 divided by any number will be 0, which is why we have the slope of a horizontal line is 0, because there is 0 vertical change. And while we're at it, we can go ahead and write the equation of this line. This would be y is equal to 4. Next, we're going to calculate slope through given points. So at the top, we had a slope formula, and I want to show you that it doesn't matter if it's y2 minus y1 over x2 minus x1, or if you have y1 minus y2 over x1 minus x2. I like to write my points underneath each other. So if I take negative 3 minus 1, that would have to be 7 minus 4 in the denominator. But I want to show you that if I opted for 1 minus negative 3 over 4 minus 7, that I still get the same slope of negative 4/3. For example 5, if I take 2 minus -2, then I have to take 5 minus 3, and I calculate that. So it has a slope of 2. So I have a denominator of 0. Anytime we have a number divided by 0, it is undefined. We can also notice that the x values are the same. So if we just sketched a graph, we would figure out that this is a vertical line going through the x value of 5. Example 7, sketch a line passing through the point 3, -2, having a slope of 1/2. So the first thing we need to do is plot the point 3, -2. A slope of 1/2 means rise 1, run 2. So if I go up 1 over 2, we should also understand that a negative divided by a negative is a positive. So we can also go down 1, left 2. Example 8, sketch a line that passes through the point -2, 5, and having a slope of m equals -2. So it might help if we put that -2 over 1. So we would go down 2, right 1. So let's plot the point -2, 5. And then from that point, we will go down 2 and right 1 and fill our graph. Also understand that we can move the negative to the denominator, and we can go up to left 1. And then connect the dots. Example 9. A line has the given slope m and passes through the first point listed in the table. Complete the table so that each point on the table lies on the line. Well, here's the way this works. The slope is basically 2 over 1. If it starts at 0, -4, and you want to plot yourself a graph, and then you go up 2 over 1, you will see that you're at 1, -2. And if you do that again, you'd be at 2, 0. And if you do that again, you would be at 3, 2. So I mentioned in another video that you might take note of what happens here is that you're adding 2 each time. Slope measures the rate of change in a quantity, including units. So keep this in mind for number 10. When a vendor sells 50 hot dogs, his profit is $36. When he sells 75 hot dogs, his profit is $66. Find the rate of change. Rate of change and slope are the same thing, but rate of change has a denominator of 1. So when you sell 50 hot dogs, your profit is $36. And when you sell 75 hot dogs, your profit is $66. So we want to find the slope. The rate of change is we want to divide 6 divided by 5. So this tells us, in terms of this particular problem, that the rate of change is $1.20. So for each hot dog he sells, his profit is $1.20. So the next page is a practice page. So I suggest you stop the video, answer the problems on the practice page, and then check your answers. And finally, our practice problem. At 1 p.m., a pool has 50,000 gallons of water. At 4 p.m., the pool has 38,000 gallons of water. At 6 p.m., the pool has 44,000 gallons of water. Find the slope of the line segment passing through 1, 50,000, and 4, 38,000. So that signifies what is happening between 1 p.m. and 4 p.m. So write the slope as a rate of change. So the rate of change is the pool is losing 4,000 gallons of water per hour from 1 p.m. to 4 p.m. Find the slope of the line segment passing through 4, 38,000, and 6, 44,000. So I would take 44,000 minus 38,000 divided by 6 minus 4. So that's going to give me 3,000. So what does this mean in terms of this problem? That the pool is filling at a rate of 3,000 gallons per hour from 4 p.m. to 6 p.m. That is it.